Today's video will be about the production process of the massive Airbus Beluga XL, and the second half is about the production of the giant Airbus A380. The Beluga XL is actually a converted Airbus A330. The original Airbus A330 will be rebuilt. They just have to enlarge the upper cabin. The basic principle of production is that large parts of the aircraft are transported to the main factory near Toulouse in France. For example, the fuselage or wings are brought here using a previous version of the Airbus Beluga ST. These main parts are assembled into a single unit at the factory. For assembly, giant cranes are used inside the production hall. Once the assembly of the Airbus A330 is complete, the aircraft will be transferred to another assembly hall where the conversion to Beluga XL will begin. First, the upper part of the fuselage is dismantled. It is then replaced by a larger cargo structure, as you can see right now. Assembly and attachment to the fuselage is done piece by piece. Beluga XL entered service with Airbus Transport in January 2020. The Beluga XL is the successor to the Airbus Beluga. However, the XL version is 30% larger. To lift heavy parts, the production operator usually uses a crane built into the roof of the factory building. After adding the tail of the aircraft, including the stabilizing ailerons, the main cargo door is installed. A total of 6 Airbus Beluga XLs were produced since 2016. The development and production of the Beluga XL cost up to $1 billion. This rebuild of the extended cargo area took only 3 months, and over 9,000 parts were used on the assembly line. Produced by Stelia Aerospace, its main freight door has 24 latches, and the nose includes the cockpit, while a 4-seat courier section is supplied by Airbus. The Airbus Beluga XL features a fully opening front cargo door for easy loading and unloading. Now the final design of the aircraft is complete, and the Beluga XL has its typical look. Compared with the time required to move the parts of an A320, a Beluga ST requires 3 times as much time to move the A330 parts. This outsized freight aircraft will now move to the testing hall at this French factory. The aircraft must pass 72 tests before it can take off for the first time. Fewer than 1,000 flight test hours were planned for its certification campaign. This is how the Beluga XL ground vibration test works. Testing takes several weeks. The flight engineers check all the theoretical calculations on the computer in practice. Everything must match the calculated values, and the aircraft must pass a demanding certification. The first testing of both engines, electronics, and control of the rudder, elevators, and ailerons also takes place here. After the successful completion of all tests, Beluga XL will again move to a special hall where the complete painting of the entire aircraft will take place. Once the surface of the aircraft is perfectly dry, factory workers apply a white primer using a spraying machine. This layer protects the whole aircraft from corrosion and is a preparation before the final paint coat. The last layer is the decorative paint. Experienced painters apply the Beluga XL markings and several other decorative elements to the fuselage. Several hundred liters of paint are used for the entire fuselage. The paint application is as uniform as possible, and the paint will last in high quality for many years. At the end of the coloring process, details are fine-tuned and mistakes are corrected with a small brush. With its bulging upper fuselage and huge cargo area, Airbus's Beluga XL is already very recognizable. The addition of a cheerful face to the distinctively shaped airframe will make it even more popular. The unusual paintwork was chosen by Airbus employees in a company-wide vote. And now the new Airbus Beluga XL can take to the skies on its first test flight. The test crew will test hundreds of different parameters and tune the aircraft's controls on the first flight. Flight tests in the air last over 500 hours. Pilots test controls, avionics, maneuverability, stability, and much more. The length of an Airbus Beluga is like 2 whales in a row. The Airbus Beluga XL is powered by 2 Rolls-Royce Trent 700 units, each providing 320 kilonewtons or 71,000 pound force of thrust. This cargo plane is as tall as a 3 floors house. The payload of the Airbus Beluga XL is 51 tons, which is like 7 elephants. The cargo compartment inside the aircraft has a diameter of 29 feet, 8.8 meters, and up to 151 feet, 46 meters long. It is 5.6 feet, which is 1.7 meters wider, and 21 feet, which is 6.5 meters longer than its predecessor, the Beluga ST. The aircraft's avionics systems were also upgraded, especially the fly-by-wire system adapted to the constantly changing center of gravity. This aircraft can carry 2 Airbus A380 wings simultaneously. Yes, that's how massive this space is. The need for the development of the Airbus Beluga XL was triggered by the strong demand for Airbus aircraft. Airbus used Antonov An-124 and An-225 Boeing C-17, Dreamlifter and A400M aircraft to transport oversized cargo. Subsequently, in 1993, he decided to develop and produce his own aircraft, thus the first version of the Airbus Beluga ST. For loading and unloading from Beluga, the airport must have a special station and a lifting trolley. The cockpit of the Beluga is pressurized, but the cargo deck is not, making it inaccessible during flight and unsuitable for cargoes that require a pressurized environment, such as live animals. The name Beluga is derived from a species of whale known for the conspicuous bump on its head that inhabits the Arctic Ocean. This is what the production process looks like for the world's largest transport aircraft, the giant Airbus A380. The oversized parts are always transported in the evening, when there is no traffic on the roads. This Airbus factory is located near the German city of Hamburg. The Airbus Beluga is used to transport the wings, fuselage, and other components for the production of the Airbus A380. All the major parts needed to build the Airbus A380 are transported from various smaller factories to the main Airbus factory for assembly. By comparison, the Beluga XL can carry 2 Airbus A350 wings simultaneously, whereas the original Beluga ST could only carry 1 wing at a time. Here the fuselage, nose, wings, and tail wing come together to form a single unit. The entire production of one Airbus A380 takes approximately 10 months. The longest production time is for all the parts such as the engines. The final assembly itself takes only a few weeks. Airbus A380 has a takeoff weight of up to 560 tons. At the airport, other airplanes have to wait up to 3 minutes before they can start their takeoff after an A380 due to the wake turbulence from its 4 engines and wingtips. Now the huge Airbus A380 will be transported down the runway to another part of the production process where all 4 engines will be installed. The A380 is powered by 4 engines, either Rolls-Royce Trent or General Motors Pratt & Whitney. Now that the A380 has all its engines, the aircraft is preparing for its first test flight. Now that the A380 has all its engines, the aircraft is preparing for its first test flight. The price of one Airbus A380 was a whopping $428 million, A lot of money, in my opinion. After the test flight, the Airbus A380 will be taken to a special hall for painting and final assembly of the aircraft interior. An airplane said to be green means finished and likely airworthy, except exterior paint and interior furnishings. That is a primer, normally sprayed prior to final painting. Zinc chromate is primarily a corrosion inhibitor. A paint layer with a thickness of 0.2 millimeters on an A380 can add a weight up to 650 kilograms, which is 1,400 pounds. Hence, more layers mean more weight. When painting an aircraft, 3 coats are used: primer, base coat, and clear coat. Each of these coatings increases the weight of the aircraft. The whole process is usually completed in 1 week to 2 weeks. Designs with tiny details take longer than normal paintings, as painters have to do finishing with paintbrushes by hand. Generally, it will cost something around $200,000 to paint a wide-body aircraft. However, in some special scenarios like the Qatar A380 paintwork, Airbus might have charged more. The paint process of this massive Qatar Airbus, called A7APA, is now complete. It takes 34 people and 15 days to repaint one A380. With infrastructure struggling to keep up with demand for landing slots and airport gates, the Super Jumbo allows the airline to increase passenger volume with fewer aircraft and fewer flights. After the painting of the aircraft exterior is completed, the aircraft is again transported to the hall for the final assembly of the passenger cabin interior. Experienced Airbus factory workers assemble all the parts of the aircraft interior like a giant jigsaw puzzle. Most of the interior elements are very variable, and the assembly is very easy. It is also possible to easily rebuild the entire interior of the aircraft after a few years. The passenger seat configuration is different for each aircraft. Airbus will make each aircraft to order from Qatar Airways. This 200,000 square meter Airbus factory is located on a 200-hectare site dedicated to Airbus and its subcontractors for aircraft development activities. Once economy class is completed on board, business class and first class seats are installed on the upper deck of the aircraft. Complete assembly of the entire aircraft interior takes only about 3 to 5 days of continuous work. Much of the work on the interior is related to the wiring and connection of all the cables in the passenger cabin. All parts in the passenger cabin are pre-manufactured and delivered to the main assembly hall by subcontractors. Of course, the first-class production in the aircraft takes the most work. That's why the price for this ticket is higher, of course. Since 2003, a total of 254 Airbus A380s have been produced, including 3 test aircraft. The A380's estimated $25 billion development cost was not recouped by the time Airbus ended production. At the end of last year, 224 aircraft were in service with 16 operators worldwide. With a theoretical maximum seating capacity of 853 seats, which is not used by any airline, the Airbus A380 consumes 2.4 liters of kerosene per 100 passenger kilometers. Of course, the first-class production in the aircraft takes the most work. That's why the price for this ticket is higher, of course. It has 40% more usable space than the second largest plane, the Boeing 747. In October 2021, Emirates announced it would receive its final 3 A380s to be delivered with the last aircraft in December 2021, thus ending production of the A380. This is what it looks like inside the Airbus Helicopters factory. They have their headquarters near Marigny Airport in France, and other factories in Germany, Spain, and the UK. In total, this division has over 22,000 employees worldwide. It was founded in 1992, and since then has focused on the production of turbines for helicopters, and of course, Eurocopter helicopters. It is the largest in the industry in terms of revenues and turbine helicopter deliveries, holding 48% of the worldwide market share as of 2024. Today, Airbus Helicopters has 4 main plants in Europe, plus 32 subsidiaries and participants around the world, including those in Fort Erie, Canada, Brisbane, Australia, Albacete, Spain, and Grand Prairie, USA. Eurocopter sold 422 helicopters per year and delivered 497 helicopters every year. Last year, AH built a concrete cylinder for testing helicopters before first flight. Some of the helicopters were renamed in 2015, resembling Airbus airplane naming. When the division changed its name from Eurocopter Group to Airbus Helicopters in 2014, the trade names of the products were changed to reflect this. Suffixes, as well as the differentiation for single or twin engines, were no longer to be used. Military versions were to be symbolized by the letter M. The only exceptions to this new branding were the AS365, the AAS 565, the Tiger, and the NH90, which will keep their current names. Competing helicopter manufacturers are Bell Helicopter, Boeing Rotorcraft Systems, Leonardo Helicopters, MD Helicopters, Russian Helicopters, and of course Sikorsky Aircraft. Airbus Helicopters was formed in 1992 as Eurocopter through the merger of the helicopter divisions of Aerospatiale and DASA. The company's heritage traces back to Blériot and Licoré et Olivier in France and to Messerschmitt and Focke-Wulf in Germany. Aerospatiale held 33% of the world's helicopter market share prior to the merger, and DASA 8%. Eurocopter's ownership was therefore split 70% to 30% between the two parent companies to reflect their respective weight in the new entity. As you can see for yourself, Airbus helicopters are built like jigsaw puzzles piece by piece. Assembly is relatively easy, but only after all the workers have been trained and the right ideas have been worked out. Airbus helicopters are known for their lower price compared to the competition. Now the finished helicopter can be pushed out and the helicopter rotor is started. The first flights are always test flights, and the test pilots test the control functions and follow a pre-prepared checklist. This is the Airbus H225M, a combat-proven multi-role helicopter. It is a twin-engined aircraft and can carry up to 28 seated troops along with 2 crew, depending on customer configuration. The helicopter is marketed for troop transport, casualty evacuation, and combat search and rescue duties, and is similar to the civilian EC-225 Super Puma. After the production process of each helicopter is completed, a series of test flights are performed. The Eurocopter EC-725 Caracal, now called Airbus Helicopters H225M, is a long-range tactical transport military helicopter developed from the Eurocopter AS532 Cougar for military use. The 11 metric ton H225M has proven its reliability and durability in combat conditions and crisis areas. Airbus H225M is counted on as a force multiplier by France, Brazil, Mexico, Malaysia, Indonesia, Kuwait, Singapore, Hungary, and Thailand. The primary improvements desired by the French Air Force were more powerful engines, greater flight endurance, and improved combat durability. Eurocopter opted to pursue development of a more ambitious derivative of the AS532 to meet this need, which was later designated as the EC725. This is what an Airbus helicopter refueling in flight looks like. The aircraft can refuel 2 helicopters at the same time. Over 200 of these Airbus H225M helicopters have been produced to date. Operating both from ships and land, even in icing conditions, this helicopter has an all-weather capability supported by night vision goggle compatibility. The helicopter's outstanding 700 nautical mile range can be extended with air-to-air or hover-in-flight refueling capabilities. This is an Airbus H145M helicopter. Let me know in the comments section how you like it. The twin-engine H145M offers the crucial capability of delivering troops and materials quickly with minimum delay, while also rapidly applying firepower to neutralize or destroy opposing forces. Considered as the reference in its civil version for law enforcement agencies, the H145M version also has demonstrated its capacity in military operations, including service with the U.S. Army, which operates the UH-72A and UH-72B Lakota variants. A key feature of the H145M is the wide range of available optional mission equipment packages that can be rapidly installed and removed based on the mission requirements. The H145M's power, range, endurance, and payload capability provide many configuration options, especially when operating in sand and dust, and in high and hot conditions at altitudes of 6,000 feet and temperatures of 95 degrees Fahrenheit, which is 35 degrees Celsius. Mission readiness of the H145M is enhanced by the rotorcraft's 2 Safran Ariel 2E turboshaft engines with dual-channel full-authority digital engine controls. Three different packages increase the aircraft's capability, from ballistic firing through helmet-mounted display to ballistic firing through an electro-optical system. This is the Airbus H160M helicopter for the French Armed Forces. It benefits from a low cost of operations and optimized flight safety. The H160M's modularity and versatility allow it to cover a spectrum of missions including commando infiltration to air intercept, fire support, and anti-ship warfare. It benefits from cost-optimized maintenance and high safety standards for flight. The H160M incorporates the latest technological achievements in French aeronautics. Weaponized for light attack operations, the H160M can quickly be reconfigured to perform various missions. A design emphasis was placed on using Airbus's production and support techniques, as used for advanced fixed-wing aircraft such as the Airbus A380 passenger jet. Accordingly, a pair of test rigs were built to separately test the dynamic and system elements respectively to speed up the design process. Up to 2 stretchers for search and rescue operations, as well as a fast rope system, cargo hook, and hoist can be used for para-public missions. It is a versatile all-in-one asset for modern armed forces. The NH-90 is a European medium-sized, twin-engine, multi-role military helicopter. It was the first production helicopter to feature entirely fly-by-wire flight controls. There is extensive use of composite materials and electronic sensors. This helicopter has 2 main versions: the TTH, oriented towards land applications, able to carry up to 20 troops, and the NFH, oriented towards naval use and focused on such tasks as ASW and Marine SAR. Over 500 have been produced for a dozen users, and it remains in production. More than 700 NH-90s have been delivered to 18 customers in 14 countries, accumulating more than 400,000 flight hours. It has an innovative features such as advanced mission flight aids and a fly-by-wire control system with an advanced 4-axis autopilot, along with a full mission-oriented integrated system. Its wide modular cabin, large sliding doors on each side, and rear ramp make it the most accessible military helicopter available. The helicopter's advanced self-protection suite is composed of laser and radar warning receivers, a missile launch detection system, and flare dispensers. Having one core training system for pilots and maintenance technicians, along with a core maintenance and spares system, also significantly reduces life cycle costs. Spain has a final assembly line at Albacete. The Marignane assembly line can reportedly complete up to 22 NH-90s per year. This is what the production of the longest version of the Airbus A350 looks like. It all starts with the delivery of the fuselage parts using an Airbus Beluga. The Airbus A350 version 1000 has a capacity of up to 550 seats and a maximum range of over 16,000 kilometers. You are now watching the production process inside the French Airbus factory near Toulouse. The body of the aircraft is bolted together, and then the wings and tail section are fitted. The last part of the production is the attachment of the landing gear and engines of the aircraft. The A350 family has 1,340 firm orders from 60 customers, of which Turkish Airlines is the largest with 110 orders. A total of 623 aircraft have been delivered as of October 2024. You're now watching the production of the Airbus A350, ordered by German airline Lufthansa. This aircraft is the XWB version, which stands for extra wide body. The process of painting the entire aircraft is carried out in a special factory hall and takes several days. Only at the end of the painting process are the pictures and the name of the airline sprayed according to the order. The color coding also acts as corrosion protection for the aircraft. The A350XWB production program sees extensive international collaboration and investments in new facilities. Airbus constructed 10 new factories in Western Europe and the US, with extensions carried out on 3 further sites. Airbus expected 10% lower airframe maintenance compared with the original A350 design and 14% lower empty seat weight than the Boeing 777. The new nose, made of aluminum, improves aerodynamics and enables overhead crew rest areas to be installed further forward and eliminate any encroachment in the passenger cabin. The new windscreen has been revised to improve vision by reducing the width of the center post. The upper shell radius of the nose section has been increased. Now the aircraft is almost ready to take off for its first test flights and then hand over to its new owner, Lufthansa. In 2020, Airbus announced that the A350 could be configured with dimmable windows. It is still one of the most popular large aircraft, whose manufacturing processes and procedures continue to improve and modernize year on year. The A350 features new composite wings with a wingspan that is common to the proposed variants. Airbus adopted a new philosophy for the attachment of the A350's main undercarriage as part of the switch to a composite wing structure. Each main undercarriage leg is attached to the rear wing spar forward and to a gear beam aft, which itself is attached to the wing and the fuselage. A new trailing edge high lift device has been adopted with an advanced dropped hinge flap similar to that of the Airbus A380, which permits the gap between the trailing edge and the flap to be closed with the spoiler. Airbus devised a three-pronged main undercarriage design philosophy encompassing both 4- and 6-wheel bogies to stay within pavement loading limits. In service, problems occurred in 3 areas: the onboard maintenance, repair, overhaul network needed software improvements. Airbus issued service bulletins regarding onboard equipment and removed galley inserts because of leaks. Recognized as the airline industry's large wide-body aircraft of reference, the A350-1000 comfortably accommodates from 350 to 410 passengers in a standard 3-class configuration, with 40% more area for premium category seating. Due to inadequate market support, Airbus switched in 2006 to a clean-sheet extra-wide body design, powered by 2 Rolls-Royce Trent XWB high-bypass turbofan engines. The Trent XWB is an axial flow, high-bypass turbofan, keeping the characteristic coaxial 3-shaft architecture of the Rolls-Royce Trent. The 97,000 pound-force engine version for the Airbus 350 maintains the same 3-meter fan size and a 5% larger core. The additional thrust will require the fan to run 6% faster, which will require strengthening to withstand the increased fan blade forces produced. The A350 family offers the ultimate passenger experience, even on the longest of flights. Its innovative design delivers a true feeling of spaciousness, with wide seats, high ceilings, and alluring ambient lighting. The A350 benefits from cutting-edge aerodynamics that provide a smooth ride and increased efficiency. Its airframe uses over 70% advanced materials, such as composites, titanium, and modern aluminum alloys to create a lighter and more cost-efficient aircraft, while increasing resistance to corrosion and reducing maintenance. The combination of innovative features results in 25% lower fuel burn and CO2 emissions for the Airbus 350 family, which is better for the environment and underscores Airbus's commitment to improving the sustainability of air travel.
To make this angel of death takes a factory like no other. Boeing's Apache plant in Mesa, Arizona. The size of 7 city blocks, it's a vast factory complex and has 2 million square feet of research and manufacturing area in Arizona's Valley of the Sun. The choice of location is important. Good weather and plenty of space to design, build, test, and fly the most successful attack helicopter in the world. Workers manufacture an average of 32 Apaches a year. In addition, Boeing repairs and renews aircraft returning from active duty. They may be refitted or modified into modern specifications. To turn an Apache from raw and naked fuselage to battle-ready killing machine takes 160 workers 3 months. And it's all done by hand, no robots here. People are better at negotiating the tight spaces inside this framework. At the center of the factory is a 15-stage production line. Known as a pulse-moving line, there are no chains, rollers, or moving walkways to advance the helicopters from one production stage to the next. Instead, the Apache is physically moved by hand, as work on each station is complete. Timing is critical. Each Apache must be moved forward in unison to completion. After 5 days in each station, it moves to the next stage in construction. Starting with the airframe, fuel tanks, cockpit, engines and rotors, electronics and sensors, and finally weaponry, turning this pile of metal into one of the deadliest brands at the military's disposal. First stage sub-assembly. This is where the metal that makes up the skeleton of the Apache takes its shape. It's no simple task, and it takes 5 of the 15 workstations to turn aluminum into airframe. Aluminum means low weight, high speed, and maximum agility for this high-tech flying machine. But the start of this build is low-tech, a process known as smashing rivets. Up to 100,000 rivets will be needed to secure this first stage of the build in place. The workers take their time. They know that more rivets equals more strength. But strength isn't enough. Above the battlefield, this machine will face flak and enemy fire. To return from battle, the entire airframe must be reinforced with body armor. The exterior of the helicopter is covered in flat structural surfaces, reinforced by a protective covering. From nearly every angle, the opposing projectile will face an armored blunt surface, which it must breach in order to damage the craft. One of the most vulnerable parts on any vehicle are the fuel tanks. To protect them takes precision engineering and some very unusual materials. This ballistic foam has been specially designed to absorb impacts. It's made from sandwich-like layers of glass in polyurethane foam that drastically slows down the speed of projectiles and absorbs their energy. The foam has been pre-cut to encase the fuel tank like a 3-dimensional jigsaw puzzle. Next, a special resin is mixed on the factory floor. The resin is designed to prevent air leaks and seals the tank in case of a bullet strike. Applied over the ballistic foam, it will also prevent any fuel from escaping should the tanks take a hit. A fuel leak on any helicopter could start a deadly fire. Finally, on top of the resin, a last layer of defense, Kevlar sheets. 5 times stronger than steel, Kevlar will stop bullets in their tracks. and keep shrapnel from penetrating the vulnerable fuel cells. Kevlar is so effective it's used by the US military and police to make bulletproof vests. Every Apache comes equipped with 2 rubber fuel tanks. Fail-safe systems are key to the endurance of this machine. Take one out, and there's a backup. The 2 fuel tanks will be loaded with 300 gallons of highly flammable jet fuel. But they're not unprotected. The rubber lining contains a special reactive agent that expands on contact with fuel. Should there be a leak, this cell will seal the hole itself. The cell is lifted into place. It's hard work, and the crew must ensure that the fuselage is free of any foreign debris that might puncture the rubber. Now, this mean machine is virtually impenetrable. The armor on the underside of the Apache is so effective that in combat, pilots will even turn their helicopter's belly to face the enemy fire. The underside acts as a shield for craft and crew. But there is one final area that needs serious reinforcement. The flight center of the Apache, the cockpit. The cockpit is a reinforced bulletproof chamber with glass up to 2 inches thick. The bulletproof side windows are surrounded by detonation explosives. In the event of an emergency, pull the trigger, and the windows fire out with explosive force, providing a quick exit from the cockpit. The Apache has 2 cockpit sections. The pilot sits in the rear, and the gunner sits in the front. The rear section is raised above the front section, so the pilot can see clearly. A transparent acrylic blast shield is mounted between the fore and aft sections, separating the 2 pilots. If one pilot takes a hit, the other can survive and fly to safety. But should the Apache go down, there is one final line of defense. The areas fore and after the cockpit are designed to buckle on impact. Like a crumple zone in a car, they absorb the force of collision and carry it away from the crew. The cockpit is the command center of the Apache, giving both pilots instant access to flight, navigation, and weapons data. There are 5 different displays in approximately 25,000 different switch combinations available to the pilots. Weapon systems, navigation, radar, communications, aircraft survivability, night sensors, day sensors, manned and unmanned teaming systems are all at their disposal. To control them takes some high-tech electronics. The electrics start out here, Station 8, the company's electrical strategic manufacturing center, a different room in Boeing's vast Apache plant in Mesa, Arizona. It may not look like a helicopter, but each of these wiring boards is the exact dimensions of an Apache. There are 11 miles of wiring in every Apache longbow, so each wiring harness must be carefully laid out to the correct length and path. The wires are secured together in bundles to make them easier to thread through the Apache. Next job, connecting the cables together. A special heat gun secures and waterproofs each electrical connection. Known as splicing, it's a way of connecting different wiring systems without risking loose connections. One loose connection could mean death for the crew and failure of the mission. Next up, the wings. It may seem odd for a helicopter to have wings, and in fact the Apache stubby wings do increase the drag coefficient, reducing the helicopter's aerodynamics. But these wings serve a vital role. They're support brackets for fuel tanks and weapons. The wings also reduce aircraft-induced vibrations during flight. This makes the weaponry easier to target. To fit the wings, workers use a precision hydraulic lift known as the wing tool. The tool holds the wing in place and straight while it's bolted tight. It also stops the heavy wing from straining the support pins during installation. Further bolts secure the underside of the wing. A special wrench is used to ensure that the torque is not too tight.